And we're now gonna do something crazy, which is we're gonna try to do this by hand, and probably means I'm gonna end up with even more frustration. Let's do this. Yeah, maybe, I don't know, we'll see. So the thing is, my current suspicion is the following, that because I was doing this wrong, right? So I was basically saying, you know, if the function is this one, right? So it's basically why is it so crazy? What's going on? No. Okay. Maybe I have to reset this. Okay, it's actually going nuts. Yeah, I mean, I'm tired. This never works well. Anyway, we'll try to do the following. So we'll try to do these with a mouse. So we have n, and then we have e to the power of minus alpha r, right? So what sorry, what we're trying to do is we have that multiplied by the conjugate, blah blah blah, and yeah, maybe just maybe we should actually use this as well, because yeah, so we have basically I think if we do the if we square this, because that's what we're trying to do, so we get, this is where I want to get, so we have this guy here, do the top shell Python, and basically what do we want to do? We want to do x to 1a py. So exactly, that's what we're getting. So we're getting at these being just having a 2 here, right? Because we squared it, blah blah blah. So, and just because we've set, okay, times n conjugate. I don't know if that's needed, but we'll see. Cool, so that's fine. Now what we're gonna do is we want to integrate that, and we want to integrate that, like, let's say, because my point is, what I fear that I'm doing wrong is, or that I was doing wrong is, that I'm like, well, this is really just a function of that x, kind of this thing with the coordinates, right? Like, it's a bummer that this doesn't work well. Whoa, what am I doing? Sorry guys. This does go nuts. This is going nuts. I don't know why. Maybe I will unplug it and plug it again. It just makes it easier with something like this, but it's not working well. Like if you had something stuck in it, I don't know. Anyway, it never really worked well. So this is really like, say, something like x, y, and z, let's say, right? And so essentially the reason we have an r here is because there is some, I'm assuming some isotropies, symmetry, hypersymmetry, whatever you call it, right? And so that's why you can express it this way. But you know, if we are going to differentiate based on these, then that's not, you know, the full picture, right? Because if I just came across this yesterday before going while I was trying to fall asleep. If I imagine a simpler case of a 2D function, and then let's say z is our domain, and so we have, say, a function that does something like, you know, kind of like a cone or something like that, where basically at each, you know, each point around this z-axis in a circular way, it's got the same distance to the center, right? And so and then it kind of have that, it has the same z value. So you don't really need to specify the function. You can specify the function as in you know, as a function of this distance, instead of using a complicated x, y, z expression. But if I want to integrate these, essentially the integration is supposed to kind of give me, let's say, do the integration, like it's kind of, you're trying to calculate in a way the area underneath these things, right? And so here you do need to do the triple integration in a way. Or I mean, if you just do these based on radius, it just gives you, my suspicion is it kind of just gives you a section of these. That's super, I'm so bad at drawing this stuff, and why I can't undo. Why can't I undo? Why aren't things working? Can I type? Yes. Why can't I undo? There you go. Whatever. So I'm getting just the I think the only thing that I'm doing is I'm getting a section of these, and so because I mean, pick whatever you want, right? But that's R. It's like you're calculating, I think, by just saying increment on R. I don't know. This is maybe I'm wrong, but maybe then you just, all you need to do is kind of give it a spin, right? And then just basically multiply by, I don't know, 2 pi or something. I to be honest, I don't know. This can be totally wrong. These guys go out, so let's just focus on these, which is e minus 2 alpha r dr, right? And then the integral of an exponential function. I mean, hell, let's just try to do these. Let's just try to integrate S1 on R. Let's just say, for the sake of, because I know the problem is going to be, let's just say R can be 0. Okay, positive, true. I think that excludes R. But let's say that is there a way to say non-zero? SymPy symbol non-zero. Can I just, like, is there like a non-zero? Declare something like non-zero and non-zero true. Okay. Because that, I think that bothers the, it can be 0. Say like these alpha can be 0, because I think this alpha just kind of tells you in a way the, someone said that in Twitter. I think it looks like it's just a way to parameterize the decay, right? Maybe that's what I was missing all the time. So I integrate these, and I integrate it across 0 and infinite. I want to see what does this tell me. Why? Wasn't there a way to say, I think, what was the what was that I was doing? I was doing something with this integration where I was saying conditions none. Oh, there you go. Conditions none. Because I don't wanna, but is this gonna give me the one that I want? That gives me this one. Okay, but yeah, in a way, I think this makes sense, because this is what I had in mind. If I do these, basically ignore this ends thing here, right? And they're just here, and then this is like 1 divided by minus 2 alpha times e, and then kind of the same thing, but then because we know it's 0 and infinite, right, we're doing sort of the infinite one, right, e to the power of infinite is just 0, so it's just going to be 0, and then minus, and then we have these things here, and then e to the power of something that is 0 is 1, so 1, right? So essentially, I think that's how you get to these. 1 divided by 2 times alpha. Now, if we look at the solution, where is the solution here? There's no 2. There's no 2 anywhere. There's no 2 anywhere. What the fuck? I kind of had the, oh yeah, wait, no, wait, but this is just this, and then like somehow I think what I'm missing is now that step of taking these two the 3 dimensions, right? Why would alpha be to the power of 3? This is what I don't know, because that would make sense in terms of why pi is there, but this I absolutely don't know how I would even approach these. Because if I think in terms of 2 dimensions, as I said, 2 dimensions and then the domain, and let's say I'm getting like just the cross section here because I'm doing it across R, right? I still need to rotate that somehow. So I still need to do, and this is, you know, 2 pi. But I don't know if you just multiply this by 2 pi. Or you just say, well, that is the derivative with respect to R. That is the I think that is the closer I've ever gotten to the solution. Something tells me that something tells me that something tells me that if I just have this solution, and let's assume that that this is just n squared and not n times the conjugate, and then this is 2a, but I still need to kind of multiply this by 2 pi, right? So the 2's go, or something like, I'm just making it up, okay? And then obviously what you want to do is you want to solve, so essentially you want to solve for these being equal to 1, and so you do n equals, and then it's like 1 times, and then it's basically a divided by pi, and then there's like a square root, right? So that's the closest I fucking ever gotten there. Oh, because this is not a square root, so this is for some reason like, you know, 3 times a square root. And the alpha is also cubed. But that's the closest, man. That's the closest I've ever gotten to the solution. And it just came yesterday as I was sleeping, like, because we know A can't be, or I think it's an okay assumption to say that A can't be 0. Why would you get A cubed though? I mean, we don't really know anything about n. It could be complex. But then again, how do you solve for these? Find the find normalization factor. Let's just watch video. See if I can.
Up to the particle in a one-dimensional box, where we determine the wave function of the system to be psi of x equals a sine n pi x over L. And this wave function had corresponding energy levels, E sub n equals 8 squared. The fixed magnitude of the wave function squared as a probability interpreted of our particle in a box. So on the left, we have the probability of finding we know that a probability should sum to 1. Or 100, any given wave is going to be located between 0 to L of psi star times psi dx. We know that A, in this case, from our wave function is just a constant. That's the constant that we're trying to solve for.
Yeah, but like, if that's a can't this be a complex constant? I thought that could just be complex, right? Why do you just go ahead and square it? I mean, if it's complex, then
So we can pull this out of our integral.
Can the normalization constant be complex? I understand it should always be positive value. If we make the choice that A0 is real, okay, so it can be constant. It can be complex.
What we're left with is the integration of from L substitution over 2 times L. Go ahead and solve for A to the square root of 2 over L times sine of n pi x over L.
Yeah, it's like, this is simple, man. This is just simple stuff. Why is it so complicated? But indeed, that's I think the closest I've ever gotten to it. So might be correct, might be not correct. I just don't know where the 3 comes in here. And I'm assuming that n is real and positive. I don't know why I would do that, but essentially that's what we have. Yeah, so n squared. Yeah, that makes sense. If I make that assumption, that kind of makes sense. That checks in, right? And then if I say please you know, times. That's the thing. That's what I'm struggling with now. How would you? Because we are now in four-dimensional space in a way. I mean, nobody's telling us really how many dimensions this has, but you assume, I guess, that X is three-dimensional. So it's kind of, you're doing a hypervolume in a way. Maybe this is just what I'm kind of missing, right? So if I have a section of the hypervolume. Isotropic. Integrating isotropic functions should be probably the right thing to look for. But this is so if the function is isotropic, exactly, okay, so then okay, times v, where v is the integral of what? This makes sense to me because the function only depends on the distance. I can choose to fix r1 everywhere in the volume, obtaining a volume term, and I will be left with this. But how can I prove that last way? So in a way, I think I'm right. Okay. Okay, so here we have a whatever theory of simple liquids this is, but you have this integral. I don't know what these things are, but I guess if it's isotropic, this means that this value is equal to actually this minus these. In a way, it's like it's just the distance between these two things, which is analog to what we're doing. And so the integral of these. Okay, but dr1 equals to I think I might have to integrate 3 times, you know? If this is correct, I might have to integrate 3 times. That's why I'm getting 3, that's why I'm getting the 3 there, I think. Wait a second, that could work. Essentially what this is telling me is that the integral with respect to one of these variables is equal to integrating across the whatever it is, this kind of radius or distance for these, for one of these things, right? But if we want to do a triple integral, then it means I just repeat. So I can actually just do, yeah. So I could just do it like that, I think. I mean, if, oh God, wait a second. So if I would have, you know, if the integral would tell me n squared divided by 2a, this is what we would have. But then the pi, where is this pi coming from? Then I don't get that. Then I don't get that. So if I want to integrate these and then dr dd, but I think I'm really close. I think I'm really close to figuring these out. I just need to make sense of these intuitively, and I think that is somewhere around isotropic functions. I just need to find the whole thing. Maybe I'll ask Mr. Twitter, right? Mr. Twitter, maybe they'll help. Maybe they'll find a way. So, question for the math people in Twitter. Functions. What's the trick? Or any exercise on isotropic function on I mean, that would be great. People know as well. Any research on integrating isotropic functions? That would be interesting, because I think I'm very close to these. Very close to these. Cool, guys. See you next time. Really, this helped. This definitely helped with the non-zero, and this definitely helped, and this helps a lot as well. Although now that I have these, probably, I don't know, that's so cool because it also kind of had some extra funky condition. Anyway, see you next time.